Hi guys, this is the first video in the series where I, as a Java and Kotlin web developer, will be learning C++ and game programming by creating my own 3D game engine with Apple Metal. Should be fun, let's go! The goal of our project is to create a macOS application that creates a new window with background painted in green, like you see on screen. Let's start Xcode and create a new project. Make sure that we are on the macOS section and app is selected. We will use storyboard and Objective-C language because I want to stay as low level as possible. Okay, we got our project created. We have a bunch of different files created for us automatically. Let's try to run it first and see what it does. Okay, so looks like it simply creates a window. Looking good. It's a good time to discuss what we are going to be building. Eventually, we will write a renderer in C++ that uses Metal APIs to draw the background of our window into green color. And the thing that we need to think about is how do we get there? Because right now we have this Objective-C application and we have a view controller that represents our window. In order to write a renderer in C++, we need to pass to it a drawable associated with the view. However, it's not that straightforward because we can't call C++ code from Objective-C classes directly. And in order to do that, we will need to create a renderer adapter in Objective-C++, which allows us to mix both Objective-C and C++ code in the same file. And from our view controller, we will pass drawable to renderer adapter. And inside of renderer adapter, we will cast it to C++ type and then call the renderer to actually do the work on the GPU. Let's try and do that. But first we will need to add metal libraries to our project because our renderer will be using metal, of course. So how do we do that? In order to do it, we need to go to build settings and add metal CPP library to the dependencies. For that we can type a header in the search window, and in this search path category we will need to provide a path to metal CPP library in header search path. So let's do that. On my machine I have metal CPP sitting in this folder here. You might have a different location and so you'll need to provide it here. On top of that, we need to make sure that implementations of metal libraries are linked with our application binaries during build phase. For that we will need to go to General and add these three pieces to this section. And after that we should go to build phase and make sure that those frameworks actually set to link with our binary. Now I think we can proceed with implementing our renderer. So let's do that. We'll need to create a new file, C++, let's call it renderer. Okay, we got header and we got C++ file as well. We won't need it here. Let me paste some code and I'll explain what it does in a second. Okay, so what we're doing, we're declaring a new renderer class, and we will be passing the drawable, which is basically an equivalent to a sheet of paper that we will be drawing onto. And also we will be passing a device, which is just a abstraction for a GPU. And we will have our destructor, and we will have a draw method that will actually do the drawing for us. In private fields of the class, we also have our drawable on device as well as the command queue, and we will look into it more as we work on the implementation later. Alright, let's move on to C++ file and add some code here. Okay, so for now I will simply add a printing to console statement in the draw method just to make sure that it works. And other than that, we simply need to implement a constructor and destructor, and we implement constructor using initialization list, so that to make sure that all our class fields are initialized when the class is instantiated. And in our destructor we simply deallocate memory for the command queue, which we will be creating in the draw implementation later, and we will talk a little bit more about those things in a bit. Oh, another big thing is that we define this 3 macro on top of the C++ file, and according to Apple documentation, they say that declaring those macros generates actual implementation of Metal CPP library. And by the way, guys, if you're interested in how exactly defining those macros generates implementation for Metal C++ headers, then stay tuned, because I will be doing a different video on that topic where we'll dig into the source code of those header files and see how exactly they work. And by doing that, we will be simulating the actual experience of Apple software engineer at work, working with those files. So I think that's pretty unique experience, and make sure to subscribe and click that notification bell so that you get immediately notified when that video is out. Now that we created the renderer in C++, we want to have a way to call this draw method from our Objective-C code, and in particular that would be view controller. So how do we do that? Well, according to Apple, the recommended approach for it would be to create a new class written in Objective-C++, which will allow us to mix Objective-C and C++ code in the single file. And all our Objective-C classes will be calling the renderer method written in C++ through that adapter class written in Objective-C++. So as usual, let me create a new file. That would be our Objective-C++ file, renderer adapter. Okay, and we will also need a header file as well. That would be renderer adapter. Make sure that target is selected here. Okay, let me paste some code here. So what we're doing here is we actually declaring a renderer adapter class in Objective-C++, and we declare a field for this class, which is actually our renderer written in C++. And as you can see, we included this C++ header here. And another thing is that we add declaration for another draw method, which, as you can see, receives the metal drawable and metal device in the same way as our renderer expects. But as you can see, these things are actually Objective-C types, right? Both CA metal drawable and MTL device, they're actually Objective-C types here. This means that our Objective-C code in view controller will be able to call this method. Okay, so let's now implement the renderer adapter, and the first thing we need to do, we actually need to change the extension of this file to be .m, and that actually tells the compiler that this is actually Objective-C++ file, and that's what we need. So let me paste the implementation of that. And so as you can see, we are implementing this draw method here, and what we're doing here is we're actually instantiating our C++ renderer with this line of code, and the next thing we do, we call the draw method, which is supposed to paint the background of our window as we need to. And as you can see, we are using pretty interesting syntax here, and essentially what we do, we actually take the Objective-C types and custom them to C++ types using this breach keyword. And breach basically says that we do this cast without transferring the ownership of the object. What that really means is that we leave Objective-C runtime responsible for deallocating memory for metal drawable when we're done working with it. That's what breach cast means. And in a similar way, we pass the pointer to metal device by casting it to C++ type here. And after that, we simply call the draw method. And another thing we have here is the dialog to clean up after ourselves, and we simply deallocate the memory for our C++ renderer, because we're still responsible for that. The last thing we need to do here is to add the implementation for this viewDidLoad method in our view controller, which will actually call the renderer adapter's draw method and pass their drawable and device. And as usual, let me paste some code. So important thing is that by adding dependency on the renderer adapter to our view controller, we actually having a situation where now our Objective-C class view controller depends on C++ code in our renderer, and that's happening because renderer adapter header depends on the renderer HPP header file, and so we transitively get a dependency, we get a C++ dependency for Objective-C file, and this will actually not compile if we attempt to do it. And to resolve it in an easy way, we just can change the view controller file extension to be a which tells it that we will be mixing a Objective-C and C++ code there. Another thing we needed to do, we actually needed to add these two fields to the view controller, and we also need to add a header file for MTK view to be known. So let's do that in view controller's header, and that would be metal-kit MTK view header. So with that, our compiler errors should be shortly resolved, and we can finally take a look at what this code here does. So the first thing we do, we actually cast the view to be a metal kit view, and we need to do it because by default the view in view controller is of type NS view, and we need it to be MTK view so that we can use metal to actually work with it. The next line of code we actually assign a device, basically a GPU, to this view. We basically tell that in order to render this view we will be using this particular GPU, and in our case we can just call this method here so that proper abstraction for our GPU will be created. The next thing we do is we actually allocate memory for the renderer adapter, and after that we simply call that draw method and pass pointers to current drawable and GPU device. Important thing to note is that we actually don't do any memory deallocation, neither for renderer adapter, neither for MTK view, and the reason we don't do it is because we have automatic reference counting enabled, and this means that Objective-C runtime will automatically deallocate memory for those objects for us as soon as they are not being used anymore by the application. So that's a nice feature of Objective-C. And the last thing we need to do before we can run our code is to actually go to the storyboard and then go to view controller scene, view controller, and change the view type to be of a metal kit view. This is a really weird and inconvenient step in my opinion, but that's actually required for this cast here to work. If we don't change the view type in the storyboard, then this cast won't work and our code won't execute properly. So that's important. And after we've done that, we can try compiling and running the application. So let's compile. Okay, we get our window and we get our hello world message from C++ renderer in the console as well, which means that we did everything well and everything is working as expected. Now that we implemented adapter pattern that allows us to call C++ code from Objective-C, it's time to talk about how do we actually implement the drawing on GPU. And to do that, we first need to take a look at how metal APIs are organized. Let's start. So in order to do some work on the GPU, we need to pass the commands using metal command queue abstraction. And command queue is organized in a way that doesn't allow us passing single commands to GPU, but rather it forces us to organize our commands in batches using command buffer. Basically, we first accumulate all the commands we need to execute on the GPU inside command buffer, and then we send this buffer to the GPU to do the actual work. And of course, GPU is implemented as a metal device abstraction in our code. So let's go back to the IDE and I'll pass the code that uses metal APIs to draw the background of the window. Okay, so let's have a look. The first thing we do is creating a command buffer. Next, we use render path descriptor to populate command buffer with commands for the GPU. And in order to understand how it works, we might need to take a look at the documentation for render path descriptor. It says this object contains a collection of attachments used as the rendering destination for pixels generated by a rendering path. I don't know about you, but to me it's not helpful at all. I didn't understand a single word here. Maybe we should take a look at the diagram and that could help us understand things better. So what the documentation trying to say is that render path descriptor receives some pixels from previous steps of rendering pipeline. Essentially, those pixels are just geometric primitives that describe the model that we need to draw. So in general case, it could look like something like this. Essentially just wireframe models. And render path descriptor generally does two things. It defines what color the pixels should have and what pixels we need to render. Those two things are configured using these different attachments. Stencil attachment and depth attachments we will not be looking at right now, but we will definitely need to in the future videos. But essentially what they do, they are used to define what parts of the model are visible to the user right now at a given moment of time. Because if you take a look at this wireframe models here, you can clearly see that if those models weren't transparent, we wouldn't be able to see the back faces, right? And if we couldn't see something, then there is no point to render it on the GPU because it just wastes performance, right? So that's the problem that those depths and stencil attachments try to solve, and they do. What we will be looking at more closely is this color attachment, because it will define what color the pixels that we need to render will have, and that's exactly what we want, because we want to render the green background for our window. Color attachment is associated with a texture, and when our pixels to render come to this step of the rendering pipeline, they need to be mapped to a texture which should define the respective colors of that pixels. And that's a simplification, because there are also other things like lighting, but we want to keep things relatively simple for now. And the thing is that we don't really have any texture, and as a matter of fact we don't even have pixels to render, we just want to set the background of the window. So in our case we neither have pixels nor the texture to map this to these pixels. However, Metal APIs are designed in a way that they still want us to set a texture for a color attachment. And so we can address this by simply using a default texture associated with the drawable that we passed from view controller. So that's what we do here. And the actual code that sets the background of the window into green is actually these two lines. And what they do is tell the GPU to fill the texture with the color that we define here, and that is green color. Next we use a render command encoder to convert this render path descriptor into actual commands for the GPU, which Metal does under the hood for us. And once that is done, we tell the GPU to present the drawable, basically display it on screen, as soon as the execution of previous command are done. And by committing, we actually send all these commands to GPU for execution. So this is important. All this code before that, this is simply a configuration. Nothing is being executed on GPU. only when we send this commit command, that's when GPU actually starts doing work. And after that, we simply release the render path descriptor that we allocated memory for earlier. So let's build and run. And yay, we actually get the window with green background. So that's all for this project. You will find the code in my GitHub repository, and I'll pass the link in the description. And let me know if you liked it or not in the comments below. And thank you guys for watching.